Exactly. Just as we were saying, we say we have two types of roofs, and we have the flat roof, and also the pitch roof. The flat roofs normally have an angle degrees of what 0 to what 10
Okay.
degrees, and the pitch are of 10 degrees and more. Exactly. Without beating about the bush, we want to what take off for what all roof members. That is, you are going to be doing take off for the purlins, the rafters, the hangers, the nodings, and all of that. Okay. But first of all, the one we want to focus on now is the rafter. That is this one. Okay. We want to focus on the rafter. So let's see how we can start with that. Okay, this is going to be our main focus of this lecture. Okay. So from here, then we're going to move to purlins, and I'm now going to be knowing the members one after the other. So this is our take-off sheet. And just as we have been saying, this is our timestamp column, this is our dimension column, this is our squaring column, this is our description column. Okay, so we can just write it as simple as T D S D. Okay, then you come over here again, the same thing, T D S D, as simple as ABC. Okay, anytime you have a work like this and you are being asked to take off for all roof members, with that, first of all, we say that the laws of measurement are the same for all observers in a uniform motion related to one another. So because of that, the laws there, you always have to maintain them, and you have to pull down the hot. Let's say the project title, the date, the scale, the SMM you are using, because you have types of SMM. Okay, the seven should tell you that it is a seventh edition. Okay, so you have to be specific, and also you have to indicate the drawing number. Okay, and all that. So over here, the first one. So first of all, you just cut. We say you cut 5 lines. Okay. In this stage, you cut five, and it's very very important, because if you don't do it, you lose marks. You will lose marks. Okay. So for the purpose of the lecture, let me quickly cut 5 lines, even before we come to talk about it. So this is 1, 2, 3, 4, 5, and I think it is okay. So over here, we're going to write what the project title. So this is the project title. This is the project title. Okay. Then in the next column, we're going to put here the date. Exactly. We're going to write over here the date. As simple as that. You have to pull down the date. Then in this next section, you can now put over here your drawing number. Okay. You can write over here your drawing number. So we can just cut it short, like just write it like this. I will just write it this way. Yeah, the drawing number, you state the drawing number. And also the SMM7 you are using. Okay, you can put even down the scale. Okay, so you have to put down the scale of the drawing. It's very, very important. Whether one is to 100 or one is to 50, etc., etc. Anyone, you need to state it. You understand me? So here you come and write the SMM7. That is standard method of measurement, seventh edition. Okay. So this is the SMM7. So 1, 2, 3, 4, 5. Then you get your marks. So how can you fail measurement of construction works? You can never fail measurement of construction work if at least you are able to keep the rules in your head. Okay. That is, you should always remember to put down your project title, the date, your drawing number, your scale, and even the SMM7 you are using. Okay. Then over here you come and write your take off list. So the sixth column is when you come and write your take off list. So let me just quickly use a different color pen to denote that, since that one is very, very important, because it's what you're going to be looking on to be doing most of your calculation. It becomes like your table of content, one way or the other. So we write over here, take off list. So this is our take off list. Then we are going to now list all the members that we want to take off for. We're going to list all the members that we want to take off for in this season. So let's start by listing them At this point, I want to take some few questions before we proceed. Do you have any question, any contribution you wish to add to the lecture to make it more effective?
No, no.
All right. So let's just quickly name them as simple as that. So the first one we say we'll be looking at is the rafter. So as simple as that. So we come and take the rafter only and we talk about it plenty. Uh-huh. Then after the rafter, we are going to be talking about the purling. Okay. Uh-huh. Just the purling I showed you the other day. That is the purling. How to know the number of purlins that you use, the number of woods you use for the building. Okay. Uh-huh. So that is the purling. They also have their dimensions, which I'm going to be throwing more lights on very soon. After the purlins, what are we going to? We are going to the hangers. I hope you have seen a hanger before.
Yes, please.
Okay, so I want to show you a hanger now, just for learning purposes. So this is a hanger. This wood you see over here, this is an example of a hanger. This is an example of a hanger. Okay. So that is it. Exactly. That is the hanger I just showed you. Then for after the hanger, we're going to be talking about the nodings. Okay. We're also going to be looking at the nodings. We're also going to like the noggins. Exactly. Then after the noggins, what are we going to look at next? We're going to look at, let's say, the roof cover. Okay. So we look at the roof cover. Okay. So even before we proceed, I want us to do some investigation. This is one, two, three, four, five. Let's go and confirm whether it is five we are supposed to calculate for. Look at the cross section. Let's now take time to count the members. Let's now take time to count the members one after the other. So let me use a different color pen so that we can differentiate it well. And I just want to use, let me use a yellow. Okay. So look, the rafter is one. Okay. And then which one again? The purling. I can see a purling over there. I can see a purling. Let's say two. Then the noggins. So we can say three. The hangers, four. The roofing sheet itself, we can say it is what? Five. What other thing? What other thing? This is the hot. Okay, so this is the purling rather over here. Okay, so this is the purling. Let me direct the purling wall. This is the purling over there. So I want to now, this is the rich cap. Okay, so we have to do for the rich cap too. So that is it. That is the rich cap. So let me now number it as our six. Let me go back to our board. So let's add the rich cap. Okay, so we have six takeoffs we have to do. That is a complete takeoff of the roof members. Please, are you with me?
Yes.
Okay. And even we can even add the approved ceiling finish too. Okay, we can also add the approved ceiling finish. So let me just add the rich cap, and then from there we just add the ceiling finish, and then we proceed. So let me add two more. So this will become my six, then seven. So this is my rich cap, and then this is the ceiling finish. The board now, the board they use the board they use, the flat plywood that they put to make it smooth that you not see anything. That at the end of the day, they paint, and that is what is called a what? Approved ceiling finish. Do you understand? This is it over here. So please, are you on the same side with me? Like, as we can just start doing some calculations now.
Yes.
Okay, so let's just pick the rafter. Okay, let's pick the rafter alone as the first member and talk about it plenty. So let me just quickly change to a different color pen. Let's pick just the rafter alone. So I want to pick the first member. That is one. So I'm now solving. Okay. So we want to just focus on the rafter only. So that is the rafter. Or if we like, maybe because in the future we may choose to add more details. We can even choose to come and start our calculation at the hot right hand side. Okay. We can even come and choose to start our calculation at this side so that if we choose to add more like takeoffs, we don't face any challenge. Okay, so let me write over here. This is the one. Okay. So we wanted to start with the rafter. So that is the rafter over there. And I'm just going to draw the rafter like I'm just going to draw a sketch of it. Okay. So you see this building over here. What is the span? So you see that this is just a cross section. They've not displayed any span over here. Okay. But we can see that span of the rafter on one of them. Okay. So that if we take even the roof framing, this is the roof framing plan. You can see the whole length. You can see the whole length of the rafter at what? 675. Can you see 675? Let me rotate this. Okay, please can you see the screen I'm sharing?
Yes.
So can you see the 675?
Yes.
This is a 675, okay. That is the whole length from this place to this place like this. That is the 675. Please, are you on the same side with me? So I'm going to draw it over here. Don't get confused. And that is the whole length of the rafter. So this is it. This is how the rafter is actually looking at in a in an elevation view. So the distance from here to here I'm talking about is the 675. 675. Zero. Okay, please. Are we on the same side? So this is the
Yes.
uh-huh. So this is the rafter over here. So this is the rafter you are seeing. Let me just use a different color pen to denote it again. So if I do this, just know that this is the rafter. Okay, this is R means rafter. So this is just rafter. Don't get confused. Okay, as simple as that. I can quickly clean one so that life is easy that way. So now we want to proceed. Okay, but first of all, we have to look for the width. Okay, and the width is what we have just found because if you come and take this drawing like this is the length. Let me quickly zoom back a bit. From this place to this place is the length. If the longest side, look at from here to here was the length of the building. You see, and the length. This is the value of the length. The length is 13350. Let me quickly rotate this so that you can see it. Can you now see the length well?
Yes.
And this is the length. So don't get confused. Exactly. So let's just put it. So it is the width that we have considered in this stage for our calculation. It is the width that we have considered. And this is just the width. And it is the width that we have considered in this our calculation. So the one I do over here, it is the width that you're actually seeing. So let me just write the width and let's proceed. So this is my width. Okay. And the width is equal to the 675 you are saying. 6750. Yes. 6750. Okay. Now we say we want to do what? We want it less. Okay. For this ones, I want to be using different color pens so that the understanding can be more understandable. So I'm going to be using this color pen. So we say we want to less. Less means subtract. Okay. So before even we proceed, let me just give you some few symbols. If it's still less somewhere, less means what? To subtract in measurement of construction way. If it's the add, add means we are doing addition. Okay. So this symbol means addition. And if it's the multiplication, if we say we are talking about multiplication, like multiply. The multiply, we normally use this sign. Okay. But if you want to divide, if you want to divide in measurement of construction work, the symbol we normally use is you now have to do something like this. You have to do like 1/2 of the thing. Okay, that is like if you want to divide the thing into two. Okay. You use a fraction, okay, to multiply the value, maybe if it's x or something that you want to divide. If you had wanted to divide it into two, then you use what? 1/2 multiplying what? The x. You understand me? But I'll try to use it somewhere so that you see how it is used. It's not anything too difficult. So you say that 1/2 is going to multiply what? Exactly if you want to divide x into two. Okay. At the same time, let's say you want to divide 20 into 4. Let's say that 20, you want to divide this 20 by 4 in measurement of construction weight. You would have said that what? 1/what? 4. Multiplying what? 20. And at the end of the day, this is going to give you what? This is going to give you what? 5. You see the logic they are using behind. Hello? Hello?
Yes, yes.
So what did I just say? Can you throw a little bit of light on what I just said so that we proceed?
You were giving me words that are used in measurements, such as when I see less is subtraction, and then add multiplication, and then the division symbol. So that's it.
So if I put k over here, then the k could be a factor. Okay. So the k could be the factor that you want the thing to be divided. You want to use to divide the thing. So the k, where k is equal to factor. So where k is equal to the factor used to divide x. So let me just quickly put it in this form for learning purposes. And let's proceed. Semedi dio semenemo. Nina Yehovah name. I be clapping more than I be talking. Okay, so that is where k is equal to um the factor used to divide. Okay, used to divide. Okay, uh-huh, by what? Multiplying. By multiplying. Okay, with the symbol. So I'm going to put a symbol in the brackets. Then you see so that when you make it somewhere again, you don't get confused. Uh-huh.
This is the buy. You've done it mine. So check it. You're typing.
Thank you. So that is where k is equal to the factor used to divide by multiplication with the symbol. Yes, the symbol I just showed you. Okay. So that is it. So this k I'm talking about, yes, where k is equal to the factor used to divide. Okay. Equal to the factor used to divide x. Okay. By multiplying with the symbol, this symbol. So to just edit this so that we run away from this, let me just edit it more better. That is where k is equal to the factor used to divide x. Okay. Uh-huh. By by multiplication what with the symbol. This. Okay. Uh-huh. So with the symbol, what is the name of this symbol? That is slash, right? Is it called a slash?
The one with the K and X.
Yes.
Yeah, it's
No, this symbol
slash.
over here, the one I just highlighted blue.
Equal to, or where
This
the K is.
no, this symbol over here, the one I just highlighted deep blue. Okay, don't worry.
The screen is closed for me. That's why. Let me see. I'm coming.
This symbol,
Can you highlight it?
the one I just circled, this one over here, what is the name?
It's slash or multiplication
Okay,
when it comes to measurement.
okay. So that is it. So we said that so this x over here, you shouldn't get confused by the x. Okay, and this is just the symbol. Okay, so we are saying that where k is equal to the factor used to divide what x by multiplication, okay, with the symbol what slash. So as simple as that. So I hope this should make you much more history. Let's go to wherever we was and let's proceed. So if we are talking about now we say we want to less, okay. After here, we say we want to less the if overhang. Okay. We want to less the if overhang. So this 675, if we really want to know the real length of the rafter, is something over here. You see that this cross section over here, there is an overhang of what? 75. This is it over here. The rafter nakasa no esha 15. Let me use red pen to show you something. And this is it. You see that
Oh,
the rafter,
Patrick, I will born ni yana. Wabɔ ne yie kakra. Ɛyɛ 750 and 75. Who confusing me?
no, the rafter is the if overhang is 75. Okay. The if roof if overhang it is 75. I'll show you soon. Don't worry. So the rafter, no, this is the rafter from here to here. Look at where the raft after here. Okay. But you see that I'll use a different color pen to try that. Look at this blue pen. This small like projection over here. Small one will be 75 I'm talking about. And I will show you for this drawing, it is not too detailed. So you may not, it may not see it well in this drawing. Okay. So let me look for a drawing that displays it more and then I'll show you the 75. So let's go to this. Let's come to this and then okay. But if it was not stated over here, in general, okay, the roof overhang because the roof has to come beyond the wood, okay, and it is 75 standard. You can quickly search that now. This is it. I've seen it. So let me just zoom it now and you see. Can you see the if roof ifs? Can you locate it
Yes,
somewhere? This is this. Can you see the 75?
yes,
So as an engineer, I'm supposed to know. Okay, so the if roof na appear beyond the wood, no, that is what they are calling the roof if, and it is just 75 mm. So we have to let it from the whole width so that we can get the actual hot length of the rafter. Okay, so that we can get the actual width. Then that width will come and divide the width into two. Then out of that we can get the whole length of the rafter. So let's just go and see how best we can proceed. And I believe that will be much more meaningful. So we want to less the 75 from this, but you know that the 75 it is two. Okay. If I say the 75 it is two, no. Look at where we pick. It is the width that we pick. We pick from here to where? Here. Okay. We pick from this place. We pick from this place up to what? This place. Okay. So you have to know that if here is what? 6750, then it means that if here there is 75 roof if over here. Here to there is what? 75. Okay. So what do we have to do? We have to add this 275. Then we subtract from this 650. That is only true when we can know the length of one rafter from here to here. And also the length of one rafter from here to here. Do you now understand me? So let's less that. And it's going to be just 2 times 75. Yeah, so it is 2 times 75. This is what I'm doing over here. So look, 2 times what? 75. And that is going to give us what? Quickly punch that, and tell me the answer. What is that going to give us? That is going to give us what? 150. Okay. That is going to give us 150. 150 millimeters. So we are going to less this from this. So now what are you going to do? You are going to say what? 6750 minus 150. 6750 minus 150.
6600.
Okay. So you're going to get 6,600. 6,600 millimeters. Okay. So from here, what are we supposed to do next? Now you see that this 6600 that we have gotten, it is actually the length of the full rafter without the if so. So now we want to know the length of just one rafter. Okay. So you can see that this is one. Okay. This is one, and also this is two. Can you see that? But the answer we have gotten it is for the full one. This is one, and this is two. And the answer we have gotten is for the two one. So if you want to know the length of one rafter, what do we have to do? We have to divide it by two. Don't you see?
Yes.
So in doing so, what are we going to do over here? Let me use a different color pen now again. So in doing so, we want to divide this 1,600 into two. We have to divide it. So in the division, I can't come and say that. No, no, no. We have to use the rules of measurement. Okay. That is because I want to do. I'll come and multiply it with what? 1/2. I want to divide it into two. So I'll multiply it with just 1/2. And if I multiply this with 1/2, what am I going to get? It's just like you dividing it. Okay. Uh-huh. So you're going to get 3,300. Yes, but before doing that, you have to cut. Yes, so you have to cut under this one like this. Okay, then you can now come and write your hot 3,300. Is that not as beautiful as that? Okay, now that you have done this, what else are we supposed to do? I'm supposed to less the block work. Let me zoom this over here. There is a block. Do you believe there is a block work over there? In
Yes.
the, thank you very much. In 10 minute time, our link is going to go off. Maybe we have to click it and come back much more stronger. So this is the block work over here you are seeing. This is the block work. This is the block work. So we have to less this block work. And the thickness of the block work is what? It's 150 millimeter. Okay, so we have to subtract this block work from the length of the rafter because we want to know the actual length of the rafter. This one is not part of this one's block. They normally break the block at the side and put the wood in it so it runs straight. And but for this one, you can see that the two woods came to meet it over here. Okay, so this block is then the two woods. So we have to subtract that. So with that, let's sort less block work. So we're going to do that same thing over there. So let me underline the less. If you write the less, underline it. So over here we say that what? Less block work. So initially I forgot to do something this time. Let me put it down. And this is what block work. We want to less the block work. So I just want to write it in short. So if I say we are lessing the block work, then it's actually what? Just because but now I want you to know something. And what must you note? This 3300, is it for the two rafters or just one rafter?
It's for one rafter.
Thank you very much. So how many are we going to subtract from this 3300?
One.
No, this time the 115, so it's going to be just 75. Do you understand me? It's just going to be 75. If it was the 6600, if it was the 6600, we would have subtracted 150 from it.
Okay.
Uh-huh. But this time, because it is just one, we will just subtract what? 75. So if I want to give you a visual form of that, then this is it over here like this. See, like this. See. So this is just the length we are calculating for. Have you seen? So that is how it looks like. So this is actually what I'm talking about. Uh-huh.
So for now, we are working on one side.
Yes, I have just focused on one side. Later, I'll multiply it by 2. If you don't do it that way, the calculation will be complicated. So this is the only one we have picked now. Okay, this is the only one we have picked now. So let me go back to the work. I want to denote something. Okay, so I just forgot to put something, and I think if I put it, it will make the work be more understandable. So that is this one over here. It's supposed to say let's roof if. Okay, for tomorrow purpose. So let me write over here roof if. So this is the roof if. So the roof ifs that we were lesson, and that was the hot 75. Okay, so that is the 2 times hot 75. 2 times 75 we did, and that is how we had the 150 to subtract from this. I hope it is more understandable.
Yes.
Thank you. So it was the 1/2. So now, as we wanted to proceed, and that is if we want to less the block work, we are just going to less 75. Okay, so we are letting 75 from this. So this is the 75 I'm putting over here. That is the block work. As simple as that. So let's subtract 75 from this. And what are you going to get?
3,225.
Yes, that is 3,225 exactly. So now we know the actual length of what? One rafter. So that is the final answer. So we can just cut it under 2 like this. You see? Uh-huh. Uh-huh. So now no, but now no, we want to know the number of rafters ebe quarter line when you now. So now we know the length of one rafter, and this is in what millimeters. Take note. This is in millimeters. For the description columns there, you can do your calculations in millimeters or meters. But if you want to come and do your squaring, you have to do it in meter. Or you have to convert it into meter. You divide by 1,000 before you can come and put it in this column over here. So let me write this one and put it in meters that way, and it's fine. So this becomes 3,225 millimeters. Exactly, exactly. So from here, now we know the length of one rafter. Okay, but you know that one rafter is what? That is let me use a pen to indicate it over here, boy. So from here up to here, to this wood like this, to this wall like this is how much? It's 3,225. You see? So let me map it. Let me map it and write it over here. And this one is the 3,225. Okay, millimeters. So that is one of that. And this one, how many do we have on this row? Now we want to know how many of these are ever quarter whole length when you know. They say the length is what 13350. So we want to know the number of meters that will go throughout the length of this building. Okay, so that is the last thing we're coming to work on now. Then we say that now we know the number of rafters I bet summer this kind of house. So that is what we want to calculate. So I'm just going to draw a diagram again, and then from the diagram we investigate that we are focusing on just one side. Okay, so this is the diagram I'm going to be putting over here like this. This is the diagram. So we've taken just one side, and it shows like a hot right angle triangle. What is the pitch of the roof? It is 25 degrees, right? Very, very necessary. So I'm going to put the pitch over here, 25 degrees. 25 degrees. Okay, so I cover it nicely. Okay. So I put over here, I'm going to write over here hot 3, 2, 2, 5. Okay. And just so that it is in millimeters. So that is from here to here. It starts off my calibration. So we've just focused on just one side. And that is the pitch. Okay. Yes. So Now, uh, you can see that this has slanted at a particular angle. Okay, so we only know, let me say, we don't know the hypotenuse. Okay, but we only know the what. If this is the opposite, we only know the adjacent. Do you realize that we only know the adjacent? Because if you pick this
Yes.
roof over here, it is all this thing. If you take the big one, the full one, it's looking like a triangle. But if you divide it into 21, you focus on just one section, you realize that you're actually having just a right angle triangle. Okay, so this right angle triangle, no, we only know the base, that is the adjacent. Okay, so now what about the hypotenuse? If we know the hypotenuse, we can easily get the opposite. Okay, so this opposite now become the hanger. You understand me? This guy now becomes the hanger. You see that this guy now becomes the hanger, and this is the rafter. This is still the rafter. Okay. So don't get confused. So, but in this case, you can see that the rafter can be considered as the hypotenuse. If you want to calculate for the rafter, which rule do you think you can use? Do you know SOHCAHTOA?
Yes.
Okay. So that is what we'll be using to calculate for our our, let me say, hypotenuse. Okay. Yes. Let's quickly do that together. And then we are going to be using the SOHCAHTOA. Okay. So in this case, if we want to calculate for the rafter, the costs have to be applied. Okay, that is costs have to be applied. So we say that what cos theta, the cos theta is equal to opposite over hypotenuse. Okay, so cos theta is equal to opposite over the what, the hypotenuse. Adjacent over hypotenuse. Okay, adjacent over the hypotenuse. Adjacent over the hypotenuse. Adjacent over hypotenuse. So that is what the cos theta is made of. So now if you want to relate this to our study, it's going to be cos 25 over the 3225 over r. That is how it's going